Hey everybody, I'm gonna kind of help you out through the 6.9 balancing chemical equations homework assignment. Feel free to kind of watch this and pause it and keep going at your own pace, especially if this is kind of confusing for you. The best thing to do is to practice, 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 rather than just write down what I'm doing. All right, let's get into it. So first thing that I do when I'm looking at a problem like this is I choose something that's not equal on both sides. So right now we have one iron on this side and we have one iron on this side. So that's not the best place to start. So I notice I have two chlorines in this one and I have three in this one. The only way to get that to balance is I put a two here and a three here. So that way I have 3 times 2. I'm gonna have 6 chlorine on this side and 6 chlorine on this side. Now I see that I have two irons, so I just need to put a 2 iron here. That'll give me 2 on this side and 2 on this side. All right. In general, when you have one kind of atom molecule plus another coming together to get one, you get synthesis. All right, let's check it out on this next one. This next one, you could start with iron, a 2 here, but it doesn't really help you much. All right, so I recommend starting with the oxygens. So I'd say you have 3 oxygens here and 2 here. That way, if you have 3 times 2, you get 6 oxygens on this side, and 2 times 3, 6 oxygens on this side. Now 2 times 2 gives me 4 total irons on this side. So that means I have to put a 4 out in front over here so I can balance it out to have 4 irons on this side. On this one, again, I have a single plus a single going to make a double. So this right here will be synthesis, also known as a combination reaction. All right, over here we have, I like to start with carbons. When I have a hydrocarbon change kind of like this, usually helps if I start with carbons. So if I have 4 carbons on this side and only 2 on this side, I'm going to put a 2 here. That gives me 4 carbons. Cool, nice, and 4 on this side, perfect. Now let's see how many hydrogens I have. Actually, you know what? Yeah, hydrogens. I have 8 hydrogens on this side already because 2 times 4. And over here, I have 6 plus this 2. Perfect. I have 8 on this side already. Nice. Now let's look at my oxygens. On my oxygens, I have 2 times 2 is 4 on this side. And this one, I have 3 from this one and just 1 from this one. So it also has 4. So I just put a 1 and a 1 here. Bam. Ooh, hydrocarbon 1 again. So I look at the carbons. I'm going to put a 2 out in front of this one. And then I look at my hydrogens, H4. That means I need to put a 2 out in this one because 2 times 2 equals 4. And my carbons have 2 on each side. Now I look at my oxygens. Now the oxygens are a little tricky because I have 2 plus 2. 2 times 2 is 4 from this molecule. So 2 times 2 is 4. And then 2 from this one right here, which would make it 6 altogether over here. And the only way to get 6 on this side is if I put a 3 over here. This would get a 1. So it looked a little something like that. Give me 6. Ooh, I forgot to do my type of reaction. This right here is, this is actually a synthesis as well because I have 2 things come together to make one thing. This one right here, because of the hydrocarbon, the oxygen, carbon dioxide, and water. On this one right here, I'd have a combustion reaction. Nice. All right, this one's a bit bigger. Here's one little trick. On this one, you can treat these polyatomic ions, this one is sulfate, you can treat them as just a single kind of unit. So SO4, if I have 1 over on this side and 3 on this side, I'm going to give this side a 3. Okay, cool. So now I have 3 SO4s on this side, 3 SO4s on this side. Iron, let's go with this one. I have 2, so on this one I have 2. So that gives me 2 irons on each side. My hydrogen, I have 3 times 2. I have 6 on this side. So that means I'm going to have to put a 6 on this side to get up to 6 hydrogens. And let's just hope my BRs already match up. 6 BRs on this side, cool. And 2 times 3, 6 BRs on this side, awesome. And what's happening here is the BR is being exchanged for the SO4. So it's going to be a double replacement reaction. Another hydrocarbon one right here. I always like to start on hydrocarbons with my carbon. So 4 here, 4 here. Cool. Next up, I have my hydrogens. I have 10 of them over here. So that means I'm going to go 5 over here. And I do my oxygens last. Now check this out. I have 4 times 2 is 8 oxygens from that first molecule. plus another 5 from this one. So I have actually 13 oxygens on this side. Now, if I take away the 1 over here, that means I have 12 left. That means I'm going to put a 6 right here and a 1 right here. Let's kind of double check to make sure I did all right. So I have 1 times 4 is 4 carbons. 4 times 1 is 4 carbons. Hydrogens, I have 10. Hydrogens, I have 10. Oxygens, I have 1 plus 12, I have 13. Perfect. Hydrocarbon with an oxygen and water, you know what's going on. It is a combustion reaction. All right, last one over here. I'm going to start not with nitrogens, but I'm going to start with hydrogens. So I'm going to go 3 hydrogens over here with 2 over here. That gives us side 6 and this side 6. This right here is 2 nitrogens. So that means I need to get 2 over here. Now I have 2 oxygen and 3 oxygen from this one. That equals 5, but look at this. Right here, I can only bring them up in even numbers in pairs. So I would want to put a 2.5 right here, but you can't put in 2.5. So what you do is I would leave it as 2.5 and then double everything. So that turns this into a 4, turns this into a 5, turns this into a 4, and turns this into a 6. And now to double check my work, I have 4 nitrogens over here. I have 4 nitrogens over here. I have 12 hydrogens on this side. I have 6 times 2, 12 nitrogens on this side. 4 plus 6, I have 10 oxygens over here. 5 times 2 is 10 oxygens. And it's looking like this one's kind of a weird one. I guess it's part of this. It's combining. I'm actually going to call it a double reaction, double replacement. It's kind of not, kind of is. Cool. All right. That's it. Thank you all. Peace.